Okay, let's get rolling. Hey everyone, welcome to lecture 6 for DSC 10. I think I know the names of everyone here, so let's see how my memory does. All right, Joel, Cece, Rio, Mary, Henry, Annie, Noah, and Ethan. Okay, if you got your name, can you give me a thumbs up? If you got your name? Cool, nice, got it. Hope you guys all had a good weekend. This past weekend, I went with a couple of friends to go strawberry picking at Carlsbad. If you're interested in something to do, we definitely recommend. It was really fun. You do have to drive like 30 minutes up north a bit, but it's just like a fun get out of town, like a fun way to get out of town, get some strawberries. And the strawberries we're nearing like the tail end of the season, but there's still a lot in the field. So if you want to go with a friend or with anyone else, just go ahead and go for it. It's really fun. All right, announcements. Lab 2 is due tomorrow at midnight. And homework 2 is due this Saturday at midnight as well. I know on Gradescope it says Lab 2 was due on Saturday, I think, and I think we just haven't updated the deadline on Gradescope since we pushed back the deadlines because of July 4th. It looks like we forgot to update the deadline for Lab 2, but I think we're going to have that handled by the end of today. So just keep a lookout for that. And even if it says that Lab 2 is due on Saturday and you made a late submission, don't worry about it. Lab 2's deadline is tomorrow at midnight. Okay, let's see. How many of you have started Lab 2? Just give me a thumbs up. Started Lab 2. Okay, how many of you have started Homework 2? Taking a look at it at least. Okay, not bad, not bad. Okay, just encourage you to keep checking on the homework. Just open it up and take a look at it when you can, because it is longer than last week's. Today we're going to be looking at queries. We're going to recap queries and then talk about how to write queries with multiple conditions. And then we're going to move to GroupBy using grouping, and then at the very end we have some challenge problems. Let's see. So last time we talked about queries. A query is code that extracts rows from a table where certain conditions are true. So for instance, last week you said, let's find all the rows that correspond to centers in the NBA, or the rows corresponding to the Los Angeles Lakers. So let's take a look. Here, we've loaded in the NBA players data set that we had from last Friday. We can now ask, who is the highest paid player on the Houston Rockets? So let me just walk you through this real quick. Here's salaries. The way we did this is we did salaries.getTeam equal to Houston Rockets. And what I showed you last time was also how to use Pandas Tutor to visualize this. Here is a Pandas Tutor visualization of this code. What we're doing here is we've gotten the team column out of the salaries table. And then we compare each element to the string Houston Rockets. And what Pandas will do is it will go down this series and ask, is this element Houston Rockets? If so, mark it as true. If not, mark it as false. And we see that all the rows here, none of the rows here are Houston Rockets, and so they're all marked false. Now there are some Houston Rockets in the middle of this series, but we just can't see them because we can only see the first and last rows by default. Now, we can use this series of trues and falses to filter rows out of a data frame by doing salaries bracket around the Boolean expression here. And we see that indeed, there are Houston Rockets in the middle of the data frame, and we're pulling them out using this query or using this filter expression up here. Okay. Now, I want to know who the highest paid player out of this data frame is. So I can take this data frame, and I can now sort it in descending order of salary. So here's a little trick that I'll do. For longer expressions, I will take the entire line of code and wrap it in parentheses. So here's an open parentheses, here's a close. And that lets me put line breaks pretty much wherever I want within the expression. So let's say I put a line break here for the query. Let's put a line break here. Let's do a line break here, and let's do sort values by salary. And let's make that ascending equals false. Okay. So here, first step, we do the filter. Second step, we do the sort. Now we see that the salaries are sorted in descending order, and Eric Gordon here is first in the list, so we can take him out But we can do that by doing dot index, because this player is in the index of the data frame, index bracket 0 to hit the first element of the index. Here we go. New line, index bracket 0. And this is what I would write to validate this code. Here we go. So here's Eric Gordon right here. One thing I didn't point out last time was that beneath this it says type class stir. What this is saying is this is a string type, even though it doesn't have quotes around it in the pandas tutor display. Okay. Great. And again, if you don't want pandas tutor, you just want the end result, you can comment out the line here. Giving a hashtag mark tells Python to ignore this line of code. And now we just get the string error. Great. So for Boolean indexing, the general idea is if you want to filter out rows, what you should do first is make a sequence of trues and falses. You want to mark the rows you want to keep with a true. You want to mark the rows you want to drop with a false. Trues and falses we call Booleans. It's named after a guy who is named I think George Boolean or something. I forget his first name. But his last name was Boolean, and he kind of came up with this idea of trues and falses. So we call trues and falses Booleans after him. And then we pass it into salaries. So we use salaries bracket, and whatever thing we have here of the trues and falses, we put that inside the brackets. Normally, we just use a comparison, though. We don't actually enter in the trues and falses by hand, although you could if you really wanted to. There are several comparisons that we can make. We saw just now that we used equals equals to denote are two things equal to each other. There are several other comparisons that we can make. Here are the most common. Here's a list of all of them, actually. A couple of things to note here is if you want not equal to, you need exclamation point equal sign. And every time you do less than or equal to or greater than or equal to, you need the equal sign after the less than sign or after the greater than sign. Oops, here we go. Okay, so that's a query using one comparison. Now let's look at queries using multiple comparisons. To have multiple comparisons for a query, we use the ampersand or the pipe symbols. Okay? The other thing you have to know is that you have to use parentheses around each query. And if you programmed in Python before, you may be thinking, oh, I should use the keywords and or. Sadly, and or do not work for queries. So there's a longer explanation for why this is the case. In any case, I'll show you an example first, and then I'll point out the things that you need to watch out for. Okay, so here's salaries. Let's say I want to find all the players who are guards. And guards includes people who are point guards, which is PG in the table, PG here, or shooting guards. These players are SG in the table, like so. So we want a table containing rows that are either PG or SG. And that tells me, because we have two things we want to query, that we want to use multiple conditions. So the first thing we can do is grab out the trues and falses for point guards. Here we go. Let's get the position. And let's do equals PG. And this is trues and falses. Let me visualize this. Okay. Trues and falses, it's only true if the player was a point guard. Now, let's say I want the shooting guards. I can do this instead. And beneath here, we have all the players who are shooting guards. And you see this player got marked with true because he had shooting guard on the left, but the point guard was marked as false. Now, in order to get players who are either point guards or shooting guards, we need to say, OK, well, anytime there's a true in either of these expressions, I want to mark my series with true. And the way we do that in pandas is, first I take the first comparison, parentheses around the whole thing, so here's open close. Here's the second comparison, parentheses around the whole thing. I put them on the same line, and then I use the pipe symbol, which is shift and the character above the return key on my keyboard, shift backslash for me on my keyboard. And there we have the pipe symbol. If I do that, then we see First, we say, okay, mark my series with true if I have a point guard. Now, mark my series with true if I also had a shooting guard. So here we see before Bogdan Bogdanovic was false, and after I apply both comparisons, Bogdanovich is true, and Raul Neto is also true. So these two players, so this player was a shooting guard, this player was a point guard, and now in this series, both the rows are true, because I used the pipe symbol. The pipe symbol stands for this or that. So if I want to query a table, now I can just wrap this whole thing in brackets. So salaries, bracket, parentheses. And here we see that we're querying positions, and in this final table we have both shooting guards and we have point guards. This line is also getting kind of long, so another way we could do a line break here is right after this pipe symbol. The reason why it's okay to do that is because Python says, okay, well there's an open bracket here, there's a closed bracket here. Everything inside the brackets is within this comparison so that I can add a line break wherever I want within this expression. Okay, so those two things are equivalent to each other. Okay. I just showed you this. Let's keep going. Okay, so let's think about this question. Let's say we want to know which power forwards on the Sacramento Kings have a salary of over $8 million. Okay, so let's break that down. We want to know of the players who are on the Sacramento Kings and our power forwards, we want to know how many of them have a salary of over $8 million. So there are three comparisons to make here. The first is we want to filter out the rows that are only Sacramento Kings. Then we want to filter that table by power forwards. And then we want to filter again to keep only the players that made over $8 million. How would I do that? First thing you can do is, let's do the first one position. Equals power forwards here. This is trues and falses. Okay. Now, let's do that. I can do and salaries dot get team is equal to the Sacramento Kings. And if I do that, we have another step. And this symbol here, the ampersand, this is Shift 7 on my keyboard. This says I will only keep the trues if both expressions are true. So in this final series here, I only mark the row with true if they are a power forward and they're on the Sacramento Kings together. So the pipe symbol says this or that. The ampersand symbol says this and that. Both these have to be true at the same time for the same row. I can do one more here. Let's do salaries.get. This is getting pretty long. We'll clean it up later. Let's do salary is over $8 million. So here's 6 zeros. Okay, so again, step 1, step 2, step 3. Let's just query the table and see what we get. So here, salaries bracket this whole thing. And since we have brackets now, I'm going to put some new lines so we can read it more easily. There we go. Okay, so what we're showing here is, on the left-hand side, we're filtering by 3 different columns. We're filtering using position, team, and salary. That's why we've drawn boxes around all 3. And here we see on the right, we have indeed just the power forwards who are on the Sacramento Kings, and all these players have salaries over $8 million. There are only 3 such players: Harrison Barnes, Marvin Bagley, and Tristan Thompson. Okay, so you give it a try. Which of these queries creates a data frame of all the centers except for Dwight Howard? And just to keep the lines of code shorter and easier to display on the screen, I have a variable Dwight, which is set to be the string Dwight Howard. So whenever you see a Dwight here, you can replace that with the string Dwight Howard. I just put that there to make the code not like wrap around the screen. So try it out. And when you do, when you have figured it out, go to menti.com or scan the QR code and give it your best shot. Okay, give you 30 more seconds for that. If you're not sure, you can just take a guess. Yes. Okay, let's take a look. We have 1A, 1B. Most people thought it was C. Let's see if they were right. Reset that. Okay, so here we have, let's first do my string here, Dwight Howard. Here we go. Here's salaries. Now, I want the data frames except for Dwight Howard. So let's first do just the centers, or sorry, just the power forwards. This should be pretty familiar to you by now. Equals power forward, we'll wrap it in brackets. Here are only the power forwards. And now we run into a problem. Problem is, Dwight Howard is in the index of the data frame, but he's not in a column. So if I try to do salaries.get player, this line here will error out because player is not a column of the data frame. Player is instead the index of a data frame. But we also know that the index of a data frame behaves like an array, behaves like a series. So if I take the salaries.index and compare each element with Dwight Howard, here's Dwight, we get an array of trues and falses, just like we would with salaries.getPosition. Both of these objects here, we can use an element-wise comparison for. And because we can use element-wise comparison for both of them, first I want the ones that are not equal to Dwight. I can wrap this in parentheses. I can use the ampersand. And then I can paste in this expression here, make sure I wrap it in parentheses, and paste it there. And we see that we have all the players that are not Dwight Howard. How do I know? I know because I can check for, I can do this, I can do .loc, or sorry, I can do, let's see, I can do index, and we can look for Dwight Howard here. So let's do, what's the best way to show you this? Maybe the best way is to do this. So here, we'll take out the Dwight. We get position equals power forward. And salaries.index is now equal to Dwight. Something went wrong. Okay, I'll try to debug this later. But basically, this is how you, the point is, you can also compare on the index. That's the point I'm trying to make. Okay, let's move on. And the right answer for that one was indeed C. So that was a pretty tricky one. I don't know how that many of you got it right unless you ran the code yourself. But if you did get it right using only just your head and looking at the code, kudos to you. That was a difficult one. Okay, let's go for group bys. So let's say we're interested in knowing which team had the highest payroll. So what we're asking here is, which among all the NBA teams, which one paid the most salary to all their players combined? We know how to do this for individual teams. So let's say we can do the Golden State Warriors, and we can do a query like this. We can say, get the rows corresponding to Golden State Warriors, and get the salary column, and then sum the salary column up. But how do we find the payroll for all the teams at once? So here we have salaries. And if I wanted to find the salaries for the Golden State Warriors, I could take salaries, bracket, salaries, zoom in, team, is equal to the Golden State Warriors. Here we have just the Golden State Warriors. I can get the salary. Here are just the salaries. And I can take the sum of the salaries. Okay. Now if I want to do this for another team, let's say I want to do it for all the teams in the NBA, I could change the string one team at a time. So I could do, let's take the Atlanta Hawks now. I could do Atlanta Hawks. Let's replace that with the Atlanta Hawks. Here's the Atlanta Hawks. If I want to do the Wizards, I can copy and paste this into here. Here are the Wizards. I can do that individually, one by one, for every single team in the NBA. I think there are 30 teams in the NBA, so I could do this 30 different times. Okay? It's kind of painful. It seems like there should be a better way, and there is. Okay, so the way that we could do this more efficiently is with using GroupBy. Let me show you what happens first, and then I'll explain what's happening behind the scenes. Here's salaries. If I group by the team column and then take the sum, we see that we have 30 rows, one for each team, and we have the total salary for each team in the NBA. So we have 30 rows, one for each team, and when I did dot sum, it counted up and added together all the salaries for each team in the NBA. So let me show you what's happening here on a smaller data frame that we'll visualize. So let's take this data frame that has some pets. It has some dogs, cat, and a hamster. It has some colors and some weights, how much these pets weigh. Let's run this data frame like so. So here's our data frame pets. Shout out to some previous pets of DSC 10. And let's take a look at what happens when we did group by species. Okay, so let me run this first and then explain. Let's take pets. Let's group by the species. If I group by the species, we see that I have colored each row corresponding to the species columns, and the dogs got put in the same color, the cats got put together, and the hamster is by itself. So when I did group by species, what Pandas does is it looks down the column and it says, okay, whichever rows have the same value in this column, I'm going to put together in a group. And when I put rows together in a group, I can now do dot sum to say find the group-wise sum instead of the sum for the entire table. So let me allow hovers here just so I can show you what happens here. So here are the dogs. We see that the dog weights got combined. We added up 40 plus 80 plus 25 to get 145 in the final row over here on the right. Here are the cat rows. The cat rows got combined by doing the sum. So here's 15 plus 20. Here are the cats. Weight is 35. And the hamster is by itself. So let's stare at that for a little more. The idea behind using GroupBy is, let's say that I just did, let's do something like, if I just did pets.sum, or let's say I did pets.get weight.sum. If I did pets.get weight.sum, then this just takes all the numbers together in the entire data frame and adds them together. Sometimes I don't want to sum up the entire data frame. Sometimes I only want to sum for individual subgroups within a data frame. To define what the subgroups are, I can use GroupBy. So I can group by species here, and I can do dot sum. So there are a couple steps that are happening. The first step that happens when I use GroupBy is, first, it splits up the data frame into its groups. Then, it takes the sum for each subgroup. So it took the sum for the dogs, the cats, and the hamster. And then the last step is that we combine all the rows together into one final data frame that contains the individual sums for each group. Any questions about this? Anything that you'd like me to try out? Yeah, Joel?
I want to know what to sum by if there's like two different columns of numbers, you know?
Yeah, it's a great question. So Joel asks, how will we know what to sum by if there are two columns of numbers? Let's say there are two columns of, like we have weight and maybe height as a second column. We'll see later. It's a good question. it turns out that pandas will take the sum for both the columns. So we'll have one column for the sum of the weights and one column for the sum of the heights. Okay, so let's go back to the MBA. Here we go, salaries. Let's visualize this. Dot group by team. Oh, let me show you what happens when you don't use Pandas Tutor for this. So if I do salaries and I do dot group by team and I'm not using Pandas Tutor, you get this output, which is like some weird, it says like data frame group by, like some really weird, some just random sequence of numbers and letters here. This is the default output for Pandas, and so what we've done with Pandas Tutor is we try to take this item here and visualize it in a more helpful way. So again, if you don't use Pandas Tutor and you just do dot group by, you get this group by object. But if you do get this, don't be alarmed. This is the normal output of using dot group by. So here we group by the teams. We see that, let me show some more rows. The Hawks are together in a group. The Celtics are together in a group. The Nets are together in a group, so on and so forth for all 30 teams in the NBA. Now, if I take the sum, okay, we see that, okay, again, let me show some more rows here. All the Hawks got put together. Okay, all the Celtics got put together here, so on and so forth. So for every team in the NBA, we've taken all the players, taken the salary column, and summed all the salaries together. It looks like the Atlanta Hawks paid their players a total of $115 million. The Celtics paid their players a total of $137 million. Okay, so in general, to use group by, we use dot group by, we pass in the column name that we want to use for grouping. It groups together rows that have the same value within the column. We group by team in the previous example, and that means that in the resulting data frame, after we do dot sum, there was one row for every unique team. After we group, we apply an aggregation method within each group. An aggregation is any method that combines rows together in some way. For example, in the last example, we used dot sum, which combines rows together by adding up numbers. The aggregation method is applied individually to each column, and here are a few more that we'll use. Dot count, dot sum, dot mean, median, max, and min. We can use any of these after a group by. I'm going to show you a couple other things. So let's do salaries. Here's the salaries before, and here's the salaries after we grouped. So what you'll see is before, the index of the data frame is the player, what are player names. And after we group by and do the sum, the index of this data frame is the team name. So the player names are gone, the team names are kept. The label of each row are the group labels. So the group labels are a thing that we'll use to determine if two rows are in the same group. Let me show you what I mean. So here, same operation. We see that before we did the group, we have John Collins here as the index. Because we use the team column to group, when we do the sum of this data frame, the team column here, which used to be just a regular column in the data frame, got moved into the index of the resulting data frame. So just keep that in mind. After you group by a team and take the sum, Atlanta Hawks is no longer a column within the data frame, but is instead the index of the resulting data frame. Now we also see that the position and team columns are just gone. Okay, so both position and team are missing from this data frame. And the reason why that happens is because the aggregation method is applied to each column. Okay? So let me show you what happens. So here we have salaries. Let me show you something interesting. Do the team. Let's do the sum again. We have just a column of salaries. But if I do dot max, we have position and salary. So why does that happen? That happens because Pandas will try to take the sum or the max for each individual column within the data frame, but if it doesn't make sense to apply to the particular column, that column will just disappear. So Pandas will say, oh, well, it looks like we can't do the sum of these positions. Let's just throw out the column. And it won't tell you that it threw out the column. It'll just do it for you. And sometimes you may find that columns are just missing that you expected for there. Why can't we do the max of strings, though? Let's take a look here. So we group by the teams, and then we took the max. What happened here? Let's take a closer look at the data. Within the Atlanta Hawks, it looks like this salary was indeed the highest, and that's why it ended up as the highest salary. But you'll see something weird, which is that this player was a power forward, but now the position is shooting guard. And in fact, every row here has shooting guard at this position, except for Cleveland Cavaliers with small forward here. So what happens here is that when we do the max of a set of strings is a string that comes last in alphabetical order. The last string in the Atlanta Hawks in alphabetical order was SG. So let's see. If we sorted the strings in alphabetical order, it looks like C would come first, and then the P's, and then the S's, and then SG would come after SF. So SG is quote unquote the maximum string. And that's why SG ends up here. Now the problem is that this salary does not belong to a shooting guard. This salary actually belongs to a power forward. And that is something that we'll look out for. I'll run by this example again later on in class. So you do have to watch out for that. And likewise, if I do .min here will take the C because C's came first in the alphabet for that particular column. So just be careful when you have strings. And know that if you do .max and .min on the column of strings after grouping, you might get some weird results. Okay, so we'll look at some more aggregation methods. Let's run through them real quick. Here's salaries, group by the team. And I can change the aggregation method just by changing what I put after the group by. So here's .sum again for the salaries. If I want to find out the average salary within each team, I just change the .sum to a .mean. Here's the average salary. It looks like this is 1 times 10 to the power of 7, which is about 10 million. Here's the maximum salary within each team. Here's the minimum salary within each team. If I do .count, I get the number of rows within each group. So how do I read this? I read this as saying the Atlanta Hawks had 11 players, Boston Celtics 13 players, Washington Wizards 12 players. Okay. So which team had the highest payroll? Let's try it out. So here, we'll take salaries. We can group by the teams. Take the sum to find the max salary. So here are the maximum salaries. These are the payrolls for each team. So to find the team that had the maximum payroll, I can do what we've done before, which is sort the values in descending order and take the first element in the index. Let's put parentheses so I can show you each of these on its own step. So here, this is what I personally like to do. I personally like to put each line on its own step here. I can do .sum, and then I can do .sort values by equals salary, ascending equals false, and then we can do .index, bracket 0. And there's a lot of steps in here. Pandas will show you each one. Salaries sorted. Utah Jazz came first as the highest salary, and so we have the Utah Jazz as the final output of this code. So many steps here, but each individual step is something relatively simple. So first we grouped, then we summed, then we sorted, then we took the first element of the index. This is pretty common for data frame operations. A lot of times you'll start off with doing something that you know is pretty simple, and then you'll tack on more things afterward to get closer and closer to the result you want. All right. How many players are there in the NBA for each position? We can do that by grouping by the position column this time and using the count aggregation And we see that there are 77 centers, 71 point guards, and it looks like there are 88 shooting guards. A lot more shooting guards than there are any other position. Okay. I do want to show you this because you have to use it in a future homework. So if you want to rename a column, the best way to do that is to assign a new column and then drop the old ones. Let me show you what I mean. Here we have a data frame, and after doing .count, we see that we have two columns, team and salary, that have the same numbers. And the reason why they have the same numbers is because when we use .count, it just counts up the rows for each column within each group. And because each column here has the same number of rows within centers, we just get 77 both times. These column names are not particularly descriptive, so even though this says salary, it's not that there are $77 for centers, it's that there were 77 centers in the NBA as players. So we don't really want either of these two columns to be named team or salary. Instead, we would like to have a column that's named, let's say, count. Okay. So the way we can do that is we can take this data frame here. We can assign, here we go, assign, and we call this column count. And we'll just take the team column and copy it over. And this is how you would do that. So we've just taken a new column called count, and we made that column by copying over all the values from the team column. So we just took the team column, copied it over. Now, we can drop the old columns. And the syntax for doing that is doing .drop with columns equals, we put in the list of team and salary, and now we have just the counts. Okay, so here, let me show you step by step. First thing we did, make a new column of count. Step 2, we crossed out these columns, team and salary, to show that we used them as columns in .drop. So team and salary gone, and now we just have the counts for each position. Okay, looks like we're doing great. Let's move on to a different data set. Let's move on to some movies. So Imdb is a website that people can go, people put movie and movie information on this website, and they also vote on how good the movie is. So it's a rating out of 10. We see that of all time, it looks like a movie called The Shawshank Redemption got 9.3, then we have The Godfather, then we have The Dark Knight. How many people here have watched Shawshank Redemption? How many people here watched The Godfather? I am not watching Godfather. How many people here have watched The Dark Knight? Okay, more people have watched that. Okay, cool. I watched The Shawshank Redemption like just a couple of years ago, and I thought it was really good. And now I want to go through this list and like watch the rest of them. Okay, so here's a data frame. This is a data frame we took from the Imdb website, and it has the top 250 rated movies. We see here The Godfather, we see here The Shawshank Redemption, here The Godfather Part 2, here's Akira down here. So it looks like Akira maybe was the 250th highest rated movie. Okay, so let's ask some questions about this data frame. Let's ask, how many movies appeared from each decade? Okay, so within a decade, how many movies were released for viewing within each decade? So here we could do that by doing grouping by a decade and then counting up the number of movies within each decade. Let's take Imdb. Let's group by the decade. And let's count the number of movies within each decade. Here we see in 1920 there were only 4. In 2000 it looks like there were 50. So movies seem to have gone better over time, or at least people who rate movies on Imdb tend to prefer the later ones, or more modern movies, than super old movies. How do we know this for certain? Well, we can plot. Let's take a plot and do y equals year. And what this will do for me is plot the number of movies in my data frame for each year. Okay, so let's run through that again. So here are the counts. Here is the plot of the years. So what did I do here? When I do dot plot with y equals year, what this does for me is it says put the index on the x-axis by default. So here are the decades on the x-axis. And then take the column and put that on the y-axis. So it takes the values in the year column and puts it on the y-axis. Now this, even though it's called year, again, because we did dot count, what this is really plotting is the number of movies within each decade that are in the top 250 IMDb movies. So again, we see that earlier on in the 1900s, not too many movies that were rated like very highly on IMDb, and as we get closer and closer to today, there are more and more movies that people thought were really good. Okay. We'll go more into plotting in Wednesday's lecture. I just want to give you a little sneak peek of it today. So what was the highest rated movie of the 1990s? We could try to do this two different ways. So the first way we could try to do this is without grouping. Without grouping, we could first, okay, so let's run through this. So try to look at this table and in your head, think about how you would find the highest rated movie of the 1990s. What we would do first, without grouping, is we could first filter down to the rows that just had 1990 in decade, and then to find the highest rated movie, we could sort by the ratings in descending order, and then once again take the first element of the index. So let's filter. IMDb.get decade is equal to 1990. We see that we just have the movies that are 1990s. So we filtered here. Jurassic Park was released in 1993. Now, I can wrap this in parentheses again and do sort by the rating. And again, I'll do ascending equals false. So here's a sorted table. And we see that, as we expected, Shawshank Redemption comes up as the highest rated movie in that particular time frame. And then we can take index bracket 0 to get the first element of the index. Let's do that. And we find at the very end we have Shawshank Redemption. We could also, now that you know about grouping, you might also think, okay, well, what if I did grouping? What if I use grouping? So let's try that. Here's IMDb. If I want to use this by grouping, then what I could do is I could group by the decade. I'm thinking I could group by the decade and then take the maximum rating within each decade. So I could group by the decade and then take the maximum rating within each decade. So here, we group by the decade. Take the maximum rating within each decade. We do get, so in 1990s, Shawshank Redemption was rated 9.2, but we see that Shawshank Redemption is gone. It's missing from the data frame because Shawshank Redemption was in the old index of the data frame, and now it's no longer in the data frame because it's not a column of the data frame. So let's fix that. What we can do here is we can reset the index to move this column of movie names back into a regular column in the data frame. I'll show you what that looks like. Okay, so one reason why I like doing like every operation on its own line is because it's easy to like insert things in between lines if I want to. So here I just did dot reset index in between the first two lines just to push that in there. And so what happens here is before this movie names were in the index of the data frame, now they're just a regular column. I group by a decade, I take the max. 9.2 belongs to, well, that's weird. So it's supposed to be Shawshank Redemption, but it's Unforgiven. And why did that happen? So again, when I did the max just says find me the last string in alphabetical order within that group. And the last string in alphabetical order in the 1990s was Unforgiven and not Shawshank Redemption. So in this case, doing the group by the max is not what we want to do, because as soon as we take the max, we disconnect the rows from each other. So this rating here is no longer tied to the movies. When we do aggregations, aggregations are applied to every column individually. Okay, so is there a way to do it using grouping? There is, and I'll leave that to you as a little exercise. See if you can figure it out. It is a little bit trickier. I'll also end with some more challenge problems. I won't have time to get through all these in class, but I just want to leave them for you for practice. So we do have solutions for them. There is a walkthrough video. What I really encourage you to do is try them out yourself before you watch the video, because when you try it out yourself, it's a lot, it really helps you remember when do I use which operation. So what I find students often struggle with is they watch the lecture and they think to themselves, like, oh, okay, like sorting values, like, I understand that. Grouping, I understand that. And then they go into homework and they're like, well, I know what sorting is, I know what filtering is, but do I sort first and then filter? Do I group by and then sort? Do I sort and then group by and then filter? So the tricky thing is not necessarily understanding what the operations are, but understanding when to use the operations and in what order to use the operations. And the only way you can really develop that skill is by practicing on your own and not just watching someone else walk through the problem. So I really do encourage you to try them out yourself. Try it out, see how far you can get. Maybe talk to a partner or someone else you know in the class, and then watch the walkthrough video, and then that'll really reinforce really reinforce that knowledge, and that should help you out for this week's homework and next week's homework especially. Okay, so here we go. We could ask, how many years have more than 3 movies rated above 8.5? Okay. Let's go through here. Out of the years with more than 3 movies, which of those had the highest average rating of movies? Which year had the longest movie titles? And what's the average rating of movies from years that had at least 3 movies in the top 50, top 250? So a little bit more complicated questions. Do check them out after the lecture and give them a shot. Okay, let's recap. So today we talked about multiple conditions. We can have queries that have multiple conditions. The thing to remember is we need parentheses around all the conditions, and we need ampersands and pipe symbols to connect conditions together. We looked at GroupBy, so we looked at how we can do .GroupBy, and then we can apply the aggregation method to each group, and that will find the group-wise sum or the group-wise mean, so on and so forth for the data frame. Okay, next time we'll talk about visualization. Thanks for coming, and I'll see you next time. Hey, Randy. How's it going?
So, yeah, I just wanted to add.
Thank you.
Yeah, by John? Yeah, by John.
A bit of a peculiar situation, but I figured I might ask anyways.
Okay, yeah, what's
So, you explain this through. So I applied for a job,
Okay.
and it was for program analyst at CADA.
Okay.
So they sent me an assessment, and I did the assessment, but my solution takes 6 minutes. It takes 6 minutes to load. So I was wondering, I don't know, like during your office hours or if you have time on Wednesday or something, if you could kind of maybe show me some pointers. I mean, I figured out how to do it, and it's a data structures problem.
Okay.
And I have not done data structures at all. I mean, it's
Okay.
supposed to be like a short assessment, but it took me like 2 days.
Okay.
You know, and I've been kind of like, you know, because we're like moving and stuff, so,
Yeah.
you know, I mean, time has been a little sparse, so I've been doing it like here and there. I mean, I even, like I messaged them, you know, I asked them, like, when do you want me to have this assessment? And then I was like, oh, once I finished, I was like, oh, thank you for letting me know, because it was fun assessment.
Yeah.
I thought it was fun. And then, but I was like, okay, well, my solution is kind of slow. But I still enjoyed it, and if there's any feedback you give me, I'd appreciate it. And they're just like, yeah, there's no time limit. You just have less time to work over this summer.
Okay.
I prefer that you spend time. I'm like, okay, well, that's not exactly what happened, but
Sure.
yeah, I don't know.
Okay.
Yeah, but I was wondering, I know it's like, it's like a job I applied for, so it's
Yeah.
fine. I get it, but I was just wondering if like you could give me some pointers or anything if you were okay with that.
Yeah, sure. Let's take a
Okay.
look at it.
Yeah. Oh, you want to see it right now? Okay, sure.
Yeah, sure.
Actually,
Let's take a
just
quick look.
install
Let's just see. Let's just see.
Yeah, you can see. So, yeah, let me just explain it real quick. So, let's see if I can just read this file in without like having to wait 6 minutes for this, and let's get the time for that.
Oh yeah, that's fine. Let me. Can you just tell me what you're trying to do?
Yeah, sure. So there's a file.
Yeah.
And the file has essentially, so there's all these ASs or whatever, autonomous systems. Actually,
Yeah.
I guess there's the instructions
Okay.
here. Yeah, so basically, they give this whole background and stuff, and that's pretty cool.
Okay.
So they have.
So it's like
should-
things are linked to each other.
Yeah.
You're trying to find a number
So
of
right,
things.
so it's just like it's a data structure problem. So I'm just supposed to sort them. Like for what AS, how many providers are there? How many times they appear with something? How many times they're a customer or something?
Okay.
And I was sorting through that. Let me see here. Yeah. So what I did was well, first of all, I dropped the example ones, and then I turned them into strings, and I split them up because they are divided by the line, right?
Oh, okay. Sure.
Yeah, I
sure.
split them up by strings, so I ended up just making 3 columns. So I have the
Yeah.
first one, the second one, and then the type of relationship.
Yeah, sure.
Yeah, and then I made that a whole data frame.
Okay.
And then I made a new data frame that has everything that they asked me for. And then I just added the 2 ASs because it has the list of all ASs and stuff.
Okay.
And then I dropped the duplicates instead if there was any duplicates or something. Yeah, and then I used the for loop, which I think is taking the thing that's taking like 6
Yeah.
minutes.
Yeah.
I was like, I don't really know how else to do this.
How many?
37,000.
Oh, okay.
Yeah.
Let's
So
see.
I was like, okay. So what I just did, I looked for locations. So I just like, for peers, like for every AS10 and I checked, are they equal to each other? Like, it just basically selected like,
Yeah.
for this number, how many I have
Okay.
the 0 relationship.
Yeah.
And then I counted the length of that, and then I put it into the peers, for example. And then I did the same thing. The data structure actually only ended up, like they have -1, 0,